is given that a string of length L hangs freely from a rigid support. The time required for a transverse wave pulse to travel from bottom to half length of string is. So here it is given that a string of length L hangs freely from a rigid support. The time required for transverse wave pulse to travel from bottom to the half of length of the string is. So basically our aim is to find out the time taken by the waves to travel from here to here, or from point A to point B. So we know that in case of string, as we are just considering a point which is at a distance, let's say x from the center, the weight of this x portion is going to act like a tension at this point. So let's say weight of this or mass of this portion is m, so tension over here will be equal to mg. So as we are moving in upward direction, the mass below it will increase and the value of tension will increase. As the tension increases, according to the relation v is equal to under root of t divided by mu, the value of velocity will also increase. So we need to consider a small element which is at a distance. So in case of string, just consider a small element over here which is at a distance x from the center, x from one end, and take it as width of the small element is equal to dx, and assume that through this portion wave is propagating with the velocity v. So if the linear mass density of this string is mu, then we can write the mass of this portion is going to be mu into x. So that tension over here we can write it as nothing but mu into x into g. Mass is mu x and tension is mass into acceleration due to gravity. So velocity at this point we can write according to the equation t divided by mu, that is under root of mu x g divided by mu. So the value of velocity is going to be x into g, under root of x into g. Now velocity, we know that velocity can be written as dx divided by dt, which is equal to under root of x into root of g. So we can write the variable together. So the value of dx divided by root x is equal to nothing but root of g into dt. Now we can integrate this expression. The value of this x is changing from 0 to L by 2, half of the length of the string, and time is changing from 0 to t. So if you are integrating this expression, root x can be written as 1 by root x can be written as x raised to minus 1 by 2 into dx, integration of this into root of g into integration of dt. So x raised to minus 1 by 2 plus 1, that is x raised to 1 by 2 divided by 1 by 2, and the limit is changing from 0 to L divided by 2 is equal to root g into dt. The integration we can take it as t, and the limit is changing from 0 to t. So we can write it as basically 2 times of under root of L divided by 2 is equal to root g into t. So the value of t can be written as nothing but 2 times of under root of L divided by g by 2. Now if you are multiplying this 2 inside, so we can take it as it is under root of 4L divided by 2g, or which can be written as nothing but 2L by g under root is the value of tension, is the value of time taken.